Okay, why don't we get started today? Uh, been a hard day getting back after break, so maybe we can get done a little early today. I'm tired already, and the class is just starting. Hopefully, you had a nice, relaxing break, or at least you worked all through break or something productive like that. I did a lot of grading over break. I spent a night at our cabin, uh, and just relaxed a little bit, went for some hikes and walks like that. So this type of year is March in Minnesota, and in my mind, March is the year the deer in our area lose their antlers. They fall off, and so I like to go for long walks and try to find lost antlers there. And so this month, I haven't found any antlers. I did find an old bone, but that's not an antler there. So, but the month is still young, so we'll see. Uh, Around my house, I live actually right in Duluth, but there are a couple really big bucks around my house, and half of them have lost their antlers, but a couple of them still have the antlers on. So I'm still hoping. So hopefully you did something fun like that over break, got to at least reset a little bit. So we are starting unit 9. So that means we're at least halfway done with this course. And I'll just warn you, the second half seems to go very fast here. So we're going to talk about virtual machines this week. We are this week and the next 2 weeks after this, we talk about how we kind of can virtualize or containerize different computing components and different things. So we start at the largest component, virtual machines, and this is what's been around for the longest time. So we do virtual machines this week, but you can't see it. But next week, Unit 10 is on what we call containers, which are smaller versions of this where we don't have an entire operating system in here. I think some of our stuff we hear today might even mention a container there. And then the week after that, we talk about microarchitectures and Lambda functions and even smaller units of computing that we can put in the cloud. So the next 3 weeks are all kind of related to this sort of stuff. The textbook talks about virtual machines again because this is the oldest structure for this. So we'll be doing that today. I'll be going over in the readings, doing that now in activities. There's a number that you can choose from different activities related to virtual machines. Like normal, you can do one of these things. And then the class exercise. I suggest if you're in class right now, you open up the exercise right now here and start working on it. So open up the exercise, particularly part 1. So it mentions a couple PowerPoints. I will go over those later on. But when I'm talking, you might want to start filling in some of this sort of stuff, especially in part 1. And then after I'm done going over the book and the PowerPoints, then we'll come back and we'll do part 2 here for that. So that's the exercise. You might want to open that up. And again, the lab will do on Thursday in class. So as far as the readings go, we're going to be doing chapter 12 on virtualization. And then I'm going to jump over and look at a couple PowerPoints with some more in-depth material here. And again, these are in here, but they're also in the exercise. Those are the same PowerPoints there for us. Yeah. So let's talk about processor virtualization. So what are we trying to do here? So basically, we are trying to run a virtual version of our machine on another machine here. So sometimes you can think about this as running it in a sandbox or a separate environment out there. There are different types of virtual machines. We're going to talk about operating system virtualization, where we're running the entire operating system in a virtual machine. And there's a couple versions of that here with what we call a hypervisor here. So a hypervisor, the book says, is software and hardware capable of instantiating and running a virtual machine. So a hypervisor is the software that runs your virtual machine. It needs to be tied to your hardware. So it has to be running on your computer, on a computer there. And not all hardware will let you do full virtualization here. A lot of modern day hardware will, but not everything can run virtual machines because we need some special characteristics that we'll see later on. And again, a virtual machine, we're going to emulate the entire computer system. We're going to try to fake the entire computer system so that it'll look like we can install software for that computer and stuff like that here. Now, here we're talking about computer systems, but we also do this for other kind of devices. So next fall, I'll be teaching our mobile apps development, and we do Android development. And so we will run an Android phone on the computer. We'll run an emulator, basically a virtualization of that Android device. So we will install the operating system. It'll look just like an Android phone. In fact, we can run different versions of Android phones on here. So it'll be just like, or basically as much like an Android phone as we want in a screen on our stuff, so that when we're writing an app, we can run it on that rather than run it on an actual phone. I mean, we'll run it on an actual phone at times too, but a lot of times when you're testing and working with the software, it's nice to have a virtual phone right there that you can be working on there. So that's certainly one. Now, at the end of this class, you have to do a final project. And one of the common final projects is to do some retro gaming where you will run a virtual version of like a Nintendo, an old, maybe older than like a Nintendo. You probably grew up with Nintendo Wii's, maybe, but maybe like a GameCube, like something old enough that we can emulate that easily on a Raspberry Pi. So we'll run like a Nintendo GameCube emulator, or there are different kinds of emulators you can run there to simulate. So then we can just take a cartridge, like with a Wii, it would have been a CD, I guess. But before that, it was these little cartridges. So we can take a cartridge and run it, take the software from that and run it right on the emulator. So emulators and virtual machines are slightly different as far as how they run underneath, how they access the memory and the OS and stuff like that. But for what you can think of, they're somewhat similar. That we're basically simulating or emulating the full operating system, the full device. All the I/O devices are emulated there. So as far as the computer or the software thinks, it is talking to this actual device with actual GameCube controllers there, even though we may not have a GameCube controller installed. So again, what is the definition of hypervisor? There's different types of hypervisors here. What type is most commonly used here? So there's two ones. One is a low level that runs right on your machine and boots right up from that machine and can emulate things. The other one works as a hosted environment. And this is the most common one, is this type 2 one. So like we'll be using that today. There's a software we'll be using later on called VirtualBox, Oracle VM VirtualBox. I'm just running that to show you. So it runs in an app. I mean, it runs in a window. It's a virtual machine. So that's what it's a hosted, it runs as an application program that manages the virtual machines. The hyper type 1, you'd have, when you boot up your machine, it would have to start up that program right then. Okay, so We will talk about a host machine, like here, my Windows environment is my host machine, and then we'll run virtual machines, which we often call guest operating systems inside that virtual machine. And eventually, again, later on today, we'll set up a virtual machine here to run in a window. So again, often you'll have a virtual machine running in a window for you to use. So um, now so this was operating system virtualization, and we will be doing that mainly, but there's also what is called application virtualization here. You can run kind of applications. They talk about this POSIX way of like running Windows somewhere. They talk about Wine. So it's Wine actually is for Microsoft Windows that lets you run these Linux-like applications here. This is all out of date. Today we use Linux Windows subsystem, something like that. Yeah, so today we run Windows Subsystem for Linux, WSL, if we're running Linux or Unix kind of stuff for Windows generally. So you can download WSL and install it, and it lets you run a lot. It's not a full Linux version, but it supports a lot of native Linux commands in Windows here for this. So it's not a virtual machine, but it lets you run Linux apps on your Windows device here. And again, on these machines, WSL is, I think, already installed here. So I can open up, I thought I could open up a command prompt. I don't know where that went, but you can run, I guess, yeah, it's already installed and you can do that. So that part of the textbook, this application virtualization, we're not using POSIX, we're using that WSL Windows subsystem for Linux available. There's other virtualizations, virtualizing a network, virtualizing a storage. So you'd fake a network connection or fake or virtual storage things. Again, nowadays, we've replaced this with containers or other things. So the only one we're going to really look at is this operating system virtualization, this first one here. So when we're trying to do operating system virtualization, what we have to do is emulate a different processor. And so again, we're running on one, like an Intel processor maybe here, but we're going to emulate a different sort of processor for this. And so how do we emulate a different processor? So when you run this, remember back to your machine instructions, we have like these assembly language that's converted into machine language, and we load in these machine language commands into our CPU and run them for that. So how are we going to, and again, we'll be accessing the memory, we'll be accessing the register, we'll be accessing all the I/O devices. How do we do that when the hardware doesn't match? So this, the most common way we do this is what is called trap and emulate virtualization. So trap means to capture the messages before, as they're going out, and then we emulate them as you go for things. So we're going to try to capture or trap the messages and then reroute them or redirect them in different ways. So So here's the fundamental trick, if you want to think of it that way. To enable trap and emulate virtualization is to handle exceptions generated by trib violations. You want to capture any messages that go out and handle them in your own code for this. So now you have to see when you're answering these questions. I don't mind in this class if you use AI to help with these. So again, I'll be going over some of these and talking about them in the textbook. And if we had a better textbook, I think I want you to pay, really be reading the textbook and doing that. But again, I'm not a big fan of this textbook. I don't think its explanations are that great. It's good. It's the best one I can find out there that hits all the topics I want. I've looked at lots of textbooks, but again, it's certainly not perfect. Not that I have better, but again, I will pull out important things here. So you can pull this out of the textbook, or you can use AI to do this and look at this also. One warning, I would keep your AI responses short. I mean, if I'm explaining this, I expect you to be able to type in a sentence or two, a couple sentences, at most a paragraph of this. If I paste this into AI, it's going to generate a half a book response. AI just likes, current AI is just like to talk, right? Here. So it's going to generate, again, basically the whole chapter. I don't need the whole chapter or a whole section of this stuff. So again, when it's doing this, yes. Like a short paragraph or read or a couple bullet points as a summary. So again, I can get a short paragraph, something that you can read and understand here. Again, my feeling is that if you're copying and pasting 2 pages of text, you're not reading it. I want something that you can be reading and understanding here if you're using AI. So make sure you're getting it at the right level, using it right ways while we're doing this. So, okay. So we're talking about that. Stuff. Let's go on to this. So again, we're trapping and doing this. So again, they're talking about how we're trying to virtualize different technologies. And again, originally at the low level, what we'd have to do with this sort of stuff in initial virtualization was that the virtual machine would send like a false instruction to the host operating system because it wasn't on that hardware. And then that would generate what we call an exception. And we would trap that exception, and then we would take that and redirect it. But the only way we get there is that it would first have to generate or go to the processor, generate an exception, we trap it, and that would is slow. Anytime we hit an exception, it slows up the processor a lot there. So what they're saying, beginning in the early 2000s, hardware was coming on for virtualization. So we didn't have to do this trap there. We could virtualize it at a higher level. So we didn't have to wait and catch these exceptions at a very low level and trap them. So initially, we were doing this sort of trap and emulate virtualization, and it is slow. And again, when I remember we used to run virtual machines, and they would run at like half the speed of a regular machine with the same thing. So now, then we moved on to para virtualization here. Okay, so most, if not all, instructions require special handling in a virtual environment that resides on the guest operating and the devices. One method for rendering guest virtualization is to modify the operating system and its drivers to explicitly interface with the hypervisor in a non-trap manner. So again, we're not going out and, we're not trying to read from the Nintendo controller, because there's not a Nintendo controller and we're getting an exception and we're trapping that. We are at a higher level saying, oh, there's a virtual Nintendo controller that you can write to, and we have the hardware in place and the software in place to do that. So most modern systems have this virtualization built into it now, so that you can do this parallel virtualization. Once you do that, your virtual machine will run nearly as fast as your host machine, because we're doing it at a different level here for this. So this is what we're often doing, is this parallel virtualization model. Sometimes we'll see, again, if you do a lot of virtualization, your BIOS your computer might not be configured there. So when it boots up, it boots into this BIOS. Remember that from a few weeks ago. At a low level, you can enable or disable virtualization. And so some machines have it available, but it's disabled in BIOS. So again, sometimes if you're working with this sort of stuff, you have to, when it boots up, go to the BIOS screen and make sure you enable virtualization so you can get access to this sort of stuff. We don't have to worry about that here. And I think most modern computers have virtualization enabled by default. So, again, there's binary translations and hardware emulations here. But again, so here we're actually trying to emulate the actual hardware low-level stuff for this stuff. Again, let's just mention, so the binary translation. So again, parallel virtualization is going to be getting this, or we're going to modify the low-level operating system so that it works with the hypervisor and we can do some stuff. Binary translation is when we're actually taking the binary code that's running and we're translating it into instructions that will run on our processor for that. So every command we have to translate into a set of commands that will run on our system there. One, we have to have low-level access to our operating system, our host operating system, and the other one, we don't have to have it, but it's harder to do so for this. Let's talk a little bit about hardware virtualization. So there's talking about these old hardware stuff. Today we see this more like if we're running a phone emulator or phone virtual machine on our computer, the processors, the hardware is actually quite different on a phone than on a computer there. So we might be running on an Intel processor here, and the one on our phone might be like what we call an ARM processor there. So it's structured, and the instruction set is different for it, low level there. So sometimes we might want to try to emulate that low-level hardware so we can bring up that whole operating system and run that. And so this talks about how, so like I said, the previous ones discussed, assume the guest operating system is expecting to run on a processor with the same instruction set as the host processor. There are situations where we can't be running that. So like an example for that is often when if you're trying to, like if you're on a Macintosh or an Apple system and you want to run a non-Apple environment there, or vice versa, because processors are often separate or different than Windows machines or, like a phone. So if you want to emulate some sort of device like that, you have to generally do this sort of hardware emulation at some point. So, let's talk a little bit about how we have to run things. So if you remember memory, we have memory on our computer, and we're not generally running directly on memory. We run virtual memory instead. So we have a virtual set of virtual memory addresses, and we have when we in a normal operating system, when a program is trying to write to memory, it is given a virtual memory set of memory addresses that writes to, and then our virtual memory system writes that out to our actual memory. And those are called page tables that translate virtual memory to actual memory. And again, we're generally needing to emulate that whole virtual memory system in our on our virtual machine, so that the virtual it's hard because there's two virtual. So the page tables on our guest machine have to match and be able to write to actual pages or actual memory on our host machine here. So talks about some what they call modern processors. So x86 processors. We used to call them like 386, 486 Pentium processors, but this is the predecessor of today's Windows machines or processors and that sort of stuff. And again, there's two main manufacturers, Intel and AMD, for these types of processors. And again, they've introduced virtualization back in the mid 2000s, so about 20 years ago there. There's another processor called ARM. ARM tends to be, well, it used to be just for small devices like phones. Then it was on phones and tablets, and then it was on phones and tablets and like Chromebooks. And then it was on, they added small laptops and like mini computers and that sort of stuff. So as ARM has grown in speed, it's expanded to where it's being used there. And RISC, this is more of a larger computer system, which we don't really see much anymore. So, okay, down to virtual tools, VirtualBox. Okay, we're going to be running VirtualBox, and I need you to download something that's going to take a little bit. VirtualBox is installed on these machines, but we need you to download an image. So if you can go to your exercise now, go down to part 2, virtual machines with virtual boxes. The second part is OS images. We're going to want to download this Linux Lite here. This is Linux Lite, and you can actually download it right here for VirtualBox, Linux Lite 7.0 for virtual thing. It is 2.6 gigabyte. You could actually download Linux Lite 5.8, which is only a 1.31. But I think in the labs here, this is going to be slow here. So for the labs, I think it's going to be much faster. If you download, I put it in my Google Drive. So if you go here to my Google Drive and just hit download here, and it's too big to scan for viruses, so you just have to download it anyway. Just download that and save it to your downloads folder or something. So we just need that. So like I've already downloaded it. I just need this file. It's a .7z. It's a zip file here. Okay, so why don't you start downloading that while I continue talking? So again, exercises, part 2, the second part of part 2 on OS images, and I would go to this one. It might be fast to download Linux Lite from Tom's Google Drive. I would suggest that. Okay, so back to the textbook. There's virtualization tools out there. There's VirtualBox. it's a free open source type 2 hypervisor by Oracle Corporation. Supports a lot of different images that can run on it. It requires hardware assisted virtualization. And so you can only run it on certain, again, hardware that supports it, but most ones do. So for most people experimenting with virtualization, we'll run VirtualBox because it's free. Now, if you're in a business, you're generally paying to run VMware. VMware is the leader in virtualization. So if you're a company and you're running virtual machines, you're running VMware often for that. And there's different versions for that. Now, there's other examples here, but again, those are the two main ones out there. And then we'll talk later on about cloud computing and running virtual machines. We've already done some of that, running virtual machines in the cloud eventually. So, okay, I'm going to leave this. Well, we were talking about VirtualBox, and it said you can run different images. I'm just going to show you those here and talk a little bit more about VirtualBox in part 2. I'm going to get back to this image later on when we get to the PowerPoint. So I'm going to come back to that. But since we were talking about VirtualBox, so VirtualBox, you can go to virtualbox.org and you can download VirtualBox. So again, if you're not in the labs, if you're unable to get to the labs, you can just download and install Virtual Labs. Here, you just have to choose like Windows and download it for Windows. Yeah, and install it that way. Okay, so that's VirtualBox. Again, it's owned by, run as an open nonprofit, but it's controlled actually by Oracle. So there's still some questions, but so far it's been okay that they're doing it that way. Now, OS images, there's a lot of it. So you can go to virtualbox.org/images and find lots of images out here. So these are their main images that are available. Well, one thing that they won't have proprietary images or operating systems like Windows or Mac OS or Apple, any sort of iOS kind of product. All those generally are proprietary, and you need a fee to get it or access it. Now, sometimes like Microsoft might be giving away Windows 11 or something like that free, but you still need a key to activate it. It's not what they do here. So there are other places where you can get this, or you can just create your own. If you have Windows license, you can install it on a virtual machine often. But again, this is running mainly these virtual machines. Some of these are well-known virtual machines like Ubuntu, Linux is really common, Fedora Linux, Debian Linux, all of these are pretty common large Linux versions. They'll also have, I think they also have things like Android and things like that might run on other devices here. So. But again, we're not going to do it. We're just going to, I picked one that's relatively small. A lot of these operating systems will be like 5 gig, and it'll take a fair amount of time to download and set up so for you. So we're going to get that running in a little bit. So I'm going to jump back to the PowerPoints here. So I just found I was looking for something that went into a little more detailed virtualization. And so these two PowerPoints I thought were pretty good. I'm just going to walk through the first part of them. This PowerPoint is 37 slides long. We'll just do probably the first 10 slides here. Just talks about what virtualization is here. Again, we're going to simulate a virtual machine, and here's this image that we'll see. It comes from a VMware white paper on virtualization and how it is set up for this. So again, we are running the big gray box is like the host machine. And inside that, we're running an application. In this case, they're talking about VMware, our hypervisor here, our software for virtualization. And then so we're running that. That's this big kind of blue box here. And then inside that, we're running multiple virtual machines. And here we're running 2 virtual machines. So again, we have one set of CPU, one memory, one network, and one disk there. So those are all resources that we have on our main computer. And then we emulate those at the low level on each of our virtual machines. So our virtual machine thinks it has its own processor, its own memory, its own network connection, and its own hard drive. So it thinks it has all those resources, but it's actually, those are simulated or virtual versions of them. And the operating system sees these virtual ones, and those are then tied to these actual ones out there. So now, how do we tie those here so that it's fast? So a lot of this talks about how we're going to do that. So again, information. So it's talking about a hypervisor or a virtual machine monitor. Basically, in our world, virtual machine monitor and hypervisor are the same. They're the software that's managing the virtual machines for us. So they talk about, again, bare metal or para or hosted virtualization. So bare metal ones will run right, our hypervisor will run right on our hardware and we'll run the VMs on top of that. What we tend to do more is this para virtualization or hosted virtualization, where our hardware runs an operating system like Windows and our hypervisor is an application in that. So again, we're running it in a window or an app in our device. So here's our hypervisor, in this case, VirtualBox, and then we'll run virtual machines within that. So these are the guest machines here. So so I talk about different ways of doing this trap or emulate, binary translation, para-virtualization. So they talk about what has to do a little bit more about trap and emulate. A trap is when an exception is generated, we catch that and we do that. So again, our app tries to direct to the operating system, or the operating system does, a trap is generated and we'll catch that trap. So so this talks about how this is set up. I'm not going to go into too much detail about this. If you're really into virtualization, you can work through this and some of the other things. I'm going to try to get down. Okay, it talks about para-virtualization here. I thought this one. No, I think it's the next one. I guess I really want to talk about the next one. So again, here's our kind of approach. Here's our physical machine without any virtualization. And then again, now we're going to install a virtualization layer here and run different virtual machines in this sort of area. And so we're going to try to do this. Now, one of the questions is why virtual machines? And virtual machines have really taken over a lot of places because we were having to set up servers that would need heavy computing or heavy hard drives at certain times, but not all the time. So we'd have a lot of wasted servers or wasted computing out there for things. And so, and we'll see another resource talking about this later on, is that we can now have a machine that'll run, 4 or 5 different virtual machines on it and efficiently kind of switch between those without having to have 4 or 5 actual physical machines. So, So one of the things we try to talk about is how we do this low-level stuff and how we do binary translation or other ways of virtualization, how we map the physical virtual space to the physical space with virtualization. So like I said, this is the traditional model. Every application has a virtual address space, and it's mapped with page tables onto a physical address space. Now, so our operating system tries to access that. Now we add something in here. We have a virtual address space that accesses this physical address space that accesses this machine actual space here. So this is what the virtual machine kind of sees. One of the questions that comes up is, how quickly can a virtual machine run? And if it's set up to run on your same hardware or use your same network, can it do that easily? Or is there software kind of in between the virtual machine and the hardware at all times? So in a good world, like let's just say a hard drive, what we'll tend to do is set up a special virtual hard drive, and we'll let the virtual machine write to that hard drive directly, and it doesn't have to go through the host operating system to write to the hard drive. And so that speeds things up a lot. Okay, I'm going to get out of here and go back to, let's go back to the exercise and talk about that. Again, so I kind of went over, I think, this diagram talking about this virtualization layer and then the operating system, the virtual machine there. Now let's try to do part 2 here. So hopefully you've downloaded the OS image here. So let's look at that. So we're going to open up the File Explorer. So here's my File Explorer. I'm going to go to my Downloads folder where it went, and it's the 7Z file. That's a zip file. I'm going to right-click on it and say Extract All. It's going to take a while to extract. For some reason, they didn't install 7-zip on these computers. So 7-zip is a very fast unzipper and zipper with this format, but this is using standard Windows zip, and so it seems like it's slow. So, but anyway, you want to just say extract all, and it should create this folder next to in the same area. So you just want to extract it to the folder. Inside that folder, there's a folder called 64 bits. Again, remember your processor, like the registers, are either 32 bits or 64 bits. So when you're working with this low-level stuff, it's important when you're installing an operating system or this stuff to install the right version. So almost all software today is 64 bits. And so that's why this is the 64-bit version. And inside that, this is a virtual disk image here for Linux Lite. It is 7 gigs. It was compressed to less than 2 gigs, but the actual image is 7 gigs here. And so this is what we're going to put on our virtual machine. So that's, we're going to want to access to that. So again, unzip this to the folder, and then you should have it. Okay, so while that's going on, let's run virtual. So I'm going back. Where's my here? Okay, now we're going to run VirtualBox. So again, if you're an online student, you'll have to download and install VirtualBox. Here, I can just, in the lab, I can just start typing VirtualBox. It's Oracle VirtualBox here. It's also, I think, under, well, oh yeah, we're in the lab. Okay, I'm going to search. So just run VirtualBox, and it should pop this up here. Now, I'm going to walk you through this. There's also this lesson that's out there that walks you through this. This is from, I think, our textbook that walks you through It's slightly older version of VirtualBox, but this kind of walks you through the general idea of what we're doing. So if you're at home or you didn't see this, you might want to just read those instructions also. Okay, but I'm just gonna walk you through. So here's our VirtualBox. We're gonna add a new virtual machine. So I'm gonna click on New. Now, there's a couple ways. There's an expert mode and a walkthrough mode. They both basically do things, but this way is going to walk us through screen by screen, which I like. So I'm going to give this a name. So Linux Lite in class. So I'm just going to give it some name for the virtual machine. Really doesn't matter what you name it. It's going to store that virtual machine in your folder in a folder called Virtual Docs. So mine is tgiven. So we just leave that as is. It knows where it wants to store it. Now, if we had a CD ROM, those images are ISO images. So if we were installing this from a CD, we could load in an ISO image. Or if we downloaded an image that was a CD image as an ISO image, we would do that here. But we are not here. So you can leave this as Linux. Here again, we can do different versions. We're going to leave it as Linux. And you can just leave this as Linux 2.6, 3 or 4, whatever, just a generic Linux sort of idea. So, okay, so that's our basic setup. Now I'm going to hit next. So again, we got to configure this. How many processors do we want to use and how much memory do we want to use in our virtual machine there. So, and you can kind of see I have up to, I can move this all way up to, I must have, I think I have like 12 gig of memory on these machines. And then I have virtual memory there. I'm going to leave this at 1 gig of memory. I don't need that much memory for this virtual machine. So I'm going to keep it at 1 gig, 1024 megabytes. Processors, again, I have how many processors do I have on this? It looks like I have 6 processors, 6 cores. Again, I'm not going to run much on this, so I'm just going to leave it as 1 core. And again, I can actually emulate more cores, and it'll simulate that it'll run slower. But if I have some hardware where I need to emulate more cores, I can. So basically, you're just going to leave this as is. Next, we're going to use the next. So again, the next thing is your hard drive. You want to create a hard drive, and they suggest creating an 8 gig hard drive, and you could create that. But we're going to use an existing hard drive image here. So we're going to click on that. And that's the image we just downloaded. We have to bring that in. So if we click here, it doesn't list it. So you've got to click on this little box over here, choose a hard drive image. It brings up this thing. You have to say add. And now go to your downloads folder, go in OS boxes, 64 bits, and then you should find your hard drive image. And then you say open, and then you say choose here. And then it should be available here. So eventually you want to get this so that it shows under you click on existing hard drive, shows Linux Lite here. So again, you will have to go here, you have to add, you have to go to your downloads, go there, find it, open it. I already did that, and it'll show up in this list here, and then you can choose that one. And it'll put it in here. So just make sure before you leave the screen that Linux Lite is here for that. Okay, so that'll get we'll boot from that hard drive image here. So again, this is a summary of what it's doing, and we can just hit finish and have our virtual machine over here. Now you can actually have, if you have multiple virtual machines, you could have multiple virtual machines listed on the left side. running different operating systems, and you could then decide which ones to run at any time. So again, and I could click on different ones. Right now, I just have this one installed. And then this is the information about it. Its name, what operating system is, how much memory, how it's booting, how much video memory it has, some, the audio, how that's configured, the network, it's tying into my network adapter, it's tying into my USB ports. You can set up a shared folder. So if there's a folder out there, you can create a folder that's available both on your virtual machine and on your host machine, and it's shared back and forth. Right now, there isn't any, and we're not going to worry about setting that up. But again, if you're working with virtual machines a lot, that's really helpful when you're moving files back and forth. Saves you having, because sometimes I've had to email folders to myself from from my virtual machine to my host machine or something like that. There. So now we're just going to hit start to get this to run. And I'll boot up the virtual machine here. And it's just kind of like starting up your phone or a new computer or whatever. It's just going to boot up the virtual machine here. It's like when we're booting up our Raspberry Pi. Also, it will go through the normal boot process of starting up this virtual machine and running it. And I'll run it in a Windows here. So we'll just let it boot up, hopefully. You see some messages here. So it is going to handle mouse integration. So again, when I move my mouse in this window, you notice it disappears because right now it's not booted up, but eventually my guest operating system would handle my mouse in that. Same with keyboard captures. When I add that window active, it'll capture my keyboards as if I'm typing it right on that host computer. So that is set up initially while I'm waiting for this to boot up. Now I only gave this one processor and I only gave this 1 gig of memory. So it's going to take me a while for it to boot up. Okay, so now I need to log in. Now on these machines, when you first download these machines, let me see if it's here. It will tell you the default username and password and a root account password for this so that you can log into. And so that's what we're going to use here. And that's what's in the instruction. So let's go back here. So here's my virtual machine. I'm going to make this a little bigger. Okay, the username I'm going to log in is OS Boxes. And again, I can always, just like your Raspberry Pi, I could create other users and delete this users. This was the username up here. I wanted to enter the password, which is osboxes.org. osboxes.org. There. Assuming I can type correctly, you should be able to log in. Only took me 2 tries. Okay. Yeah, I'm going to hide some of this so that we can see it a little better. So again, this is a whole different environment, but again, you've already been using your Raspberry Pi, so this should look somewhat familiar. I mean, you've seen different environments here. So here's, this is just Linux. So again, I think this is my file manager. I can bring this up and look at my files. I can see my user files here and work with those. I'm wondering if I can, I thought I could get rid of this display. Okay, I can click on this little display to get rid of it or just minimize it over here. There's a web browser. I can run Firefox. It looks like is pre-installed for this. So I can run Firefox. Now, on this version of Linux, all the commands are at the bottom, kind of like Windows. Remember, on your Raspberry Pi, I think they're all at the top. Now there are commands at the top, but these are the OS, the virtual machine commands. So I can, configure like the optical drive, the CD-ROM, or the network, or the USB. So if I plug in a USB device, do I want that available to this virtual machine or not, and things like that. So I can configure all of this. So this menu up here is the virtual machine menu. This menu down here is the actual operating system options. So that you know. Now I can also run this full screen here. So let's see. Okay, yeah. So this is full screen mode. I'm surprised this isn't. So again, now I'm running this in full screen mode here. So it's basically taken over my screen. I'm still running Zoom here, so some of my Zoom stuff is showing up because Zoom is special. But again, this is running full screen. So often, again, you can run this, and rather than running in a window, it'll seem like you're on that virtual machine in this mode for this. And again, we've got rid of the menus at the top. And so these are just the Linux menus down here at the bottom that I can get access to. Okay, and then to get out of full screen, I thought it was Control H, Control F. There. I think if you move down to the bottom of your screen, it pops up the little menu and you can run it outside of full screen mode. And I think this will run it. I thought that one ran in full screen. Maybe not. So again, I can go to full screen. Yeah, host F. But again, if you see this little bar at the bottom, you can click on that and run this window again. That will work also. Okay, so that's our virtual machine. I'm just going to leave that up and running for a sec. And again, here's my Oracle virtual box manager. It shows a preview of what's running. It shows that it is running here and active here for this. And if I want, I can pause this, or I can stop it. I can tell it to shut down or power off for this. I can also show it. If I hit show, it'll show that virtual machine for this. So, okay, what do you need to do for this? So again, we just want you to get this virtual box and go do a screen capture of this. So again, just bring this up. I think these, I do the Windows Shift S and show a capture of this screen running and post that in here. Oh. Okay, then we just have part 3 left here. And again, this talks about virtual machines in the cloud. Now, we've already run virtual machines in the cloud, so we're not going to do that again. We're just going to talk a little bit about them. Microsoft has a number of cool free books on this sort of advanced architecture. And one of them we'll pull up now is this Azure for Architects. Azure is the Microsoft cloud. Amazon calls it AWS. Google calls it cloud, of course. And then Microsoft calls it Azure. So this is a full book, a 700-page book about this. It's somewhat old, not too bad. But again, if I go down to here, let's see. Chapter 1 talks about virtualization on page 14. So again, it talks about lots of stuff about their cloud things. Again, 700 pages of stuff, but I'm just going to go to page 14 where it talks about virtualization. Again, they're trying to sell virtualization and Docker containers and that sort of stuff. So this is half sales pitch, half educational. So virtualization was a breakthrough innovation that completely changed the way physical servers looked. Oh, that is so exciting. I want a virtualization. It refers to the abstraction of physical objects to logical objects. Virtualization of physical servers led to virtual servers known as VMs. These VMs consume and share physical CPU, memory, storage, and other hardware on hosted things. This enabled fast, easier provisions and reduced better scalability and reduced cost. One physical server could host multiple VMs there, but then, and one thing we'll see is each VM contains its own entire operating system. And next week, we'll look at containers. Containers will not have the full operating system installed, but VMs do. So VMs contain a whole operating system for this. In Azure, you can create Linux and Windows VMs in a few minutes. And again, we've seen how to do that. And you might notice the next chapter or the next section here is containers, and that's next week. So next week, we'll probably be back here reading about containers. So again, what is one of the advantages of virtual machines? So again, you don't need a physical machine there. You don't need or you can run. So again, we used to have, I think, 30 servers just to run our campus down in our basement. We'd have 30 servers down there. And then virtual machines took over. And so now we can run like 4 or 5 servers, and we can run a bunch of virtual machines on them. And that's where we were maybe 5 years ago. Now, a lot of our stuff is now in the cloud. So we have very few actual physical virtual machines around for this. And it used to be, again, if you ran it on physical hardware, at some point you outgrew that hardware. You needed something faster. You needed more memory. Sometimes you could put in more memory in your server, but you couldn't necessarily make it faster. So then you'd have to buy a whole new server, and then you'd have to copy all the data, reinstall the operating system application, and move everything over. It'd take you weeks, if not a month, to move over to a new server and bring that new server up there. But nowadays with virtual machines, especially in the cloud, you can just log in the virtual machine and give it more memory. Same here. I could go into this virtual machine here, even on my thing, and just say, oh, I need this to have more memory, or right now it only is accessing one of the cores. I need to access 2 or 4 of the cores because it's going to be in demand coming up. So you can have that. So the other thing is AWS. We don't want to just pick on Microsoft here. So what is virtualization here? Why is virtualization important? So a good example is just the email server. We can store the business email securely. We can run customer-facing applications, internal business stuff. It makes very efficient use of hardware. It basically turns what we call infrastructure into a service. You'll hear the SaaS model, not something as a service, where you don't have to do it yourself. You pay someone to do that. At one point, we tried meal prep as a service, where we paid this, we get a thing in the mail, a little package in the mail, which would be a prepared meal. Well, it would be all the food cut up. We had to cook it. So I don't know what, like chef in a service kind of stuff. So it would have all the vegetables cut up and the meat, and we would do everything measured and everything. And you would just follow in a recipe, and you just follow the instructions. That was just as a service. We tried that for a while. It had some good recipes. Now we just use those recipes. Well, I don't mind going to the grocery store and buying stuff and having food in my house. I think those are all good things. But for some people, that's really nice there. So again, Amazon is trying to sell this. Amazon is by far the world's leader of this stuff. So what are the three benefits of virtualization here? You're thinking, I don't have time to read this, right? So we're just going to take that. Read this text. And what I want, what are three benefits of virtualization? Let's see how that goes. I've been testing AI. Well, this morning's class, I teach a class in machine learning. We've been looking a lot at different machine learning models and prompt engineering and that sort of stuff. So I've been actually trying out the different models here. So this is the, again, 4.0, a really simple model here. But again, this is not very helpful. I mean, I could, if I wanted that, I mean, that was just written right here. What are the benefits, the three benefits there? So I wanted it to summarize that because I mean, that's what you want. We just want 3 bullet items with these 3 things in it, right? And again, it is giving me a long thing. So can you condense this down to 3 short bullet items? I'm kind of worried that AI is going to hurt my spelling. I'm not a good speller, but I've been forced in a lot of places to spell correctly because often the computer, like the program, you know, when I do programming stuff, it doesn't recognize it. And Google used to not recognize it if I didn't, when I tried to search something and I didn't spell it exactly correct. But nowadays with Google or with AI, not to spell it correct. And I think it's going to ruin my spelling abilities. So, okay, that's better. So again, what are we looking at? We're this efficient resource use. We don't have, often we had hardware out there, servers that we only use 10% of them, but we thought we might need more in the future. Automated IT management. Again, we don't have to physically set up these servers. And again, fast disaster recovery. Here, if our server goes wrong, we have it as an image generally, and we can just bring up another server or something like that. So, all right. So Thursday, we'll be coming back here and we'll do the lab on Thursday. Sound good? Oh, you should shut down your virtual machine. So let's go to our virtual machine. I'm going to go there and how do I shut this? I'm just going to choose to shut it down there. I'm going to actually shut it down. You can actually just shut it down Hyper-V because it's not like that. But generally, I like to shut down the machine. I'm going to power off the machine here. And I'm going to close that. And then I'm good. All right.